Okay, these are more problems from section P3. This is number 84, and it was just the 1/2. I'm going to simplify this, 121 to the 1/2 power, but the 1/2 is the same thing as the square root, and the square root of 121 is 11, because 11 times 11 is 121. Over here, we have 125 to the 2/3, so we could write this as the cube root, where 1/3 is the cube root of 125 squared. And the cube root of 125 is 5, because 5 times 5 times 5 is 125. Then 5 squared is equal to 25. Now remember, we said root first, power second. So we're using basically the theorems or the definitions we were given. But again, you could just root first. You could say the cube root of 125 is 25, and 25 squared is 5. I'm sorry, the cube root of 125 is 5. 5 squared is 25. So you just could have gone right into that. Okay? And then over here, we've got 16 to the negative 5 halves. And remember, one of the definitions we had, or the rules we had, is the same thing as 1 over 16 to the 5 halves. And again, you could root first, power second. Okay, now if I root first, I'm going to take, this is the square root of 16 to the 5th power. What's the square root of 16? 4. What's 4 to the 5th? Well, 4 times 4 is 16, times 4 is 64, times 4 is 256. Times 4 is 1024. Okay. That's 96. I'm sorry, that's 90, pardon me, 90. And then 93. We had a fraction over here. So I broke this up. Remember, we are dividing these numbers, but we are taking the difference of these exponents. Remember, when we divide with powers, we take the difference of the exponents. When we divide with numbers, we just divide. So I wrote 20 over 5, and then x to the 1/2 minus 1/4. And 20 over 5 is 4, and then I've got 1/2 minus 1/4. I had to make a common denominator to subtract these fractions, so I made this as 2/4. What's 2/4 minus 1/4? 1/4. So just 4x to the 1/4. Okay, 96. Okay, x to the 4/5 times 5, so I'm going to multiply. So this is be x to the 4/5 times 5 over 1. And these cancel, or you can think of it as 20 over 5, which is 4. And 99. This was 97. I copied that down by mistake. If you want to see 97 just for extra practice, you could look at 97. And I did the same thing with 102. This was 103. I copied these down wrong, so I'll show you these in just a second. So there's 97 and 103 if you just want to see some extra problems, just for help. And let's go over here. Let's take a look at 99 in our homework. And this is what we had. Looks like a rather formidable problem. So we have 3, and I just put a 1 here because it's understood to be 1. Y to the 1/4, and that's to the 3rd power over y to the 1/12. So remember, when we are raising the powers, we multiply the exponents. So 3 times 1 is 3. 3 times 1/4 is 3/4. This stays the same. And then what's 3 cubed? Well, 3 times 3 is 9, times 3 is 27. And then I'm dividing, so this would be y to the 3/4 minus 1/4 power. And again, so remember, when we're dividing, we subtract the exponents. When we are subtracting fractions, we have to have a common denominator. So I made the denominator 12. I multiplied the top and the bottom by 3 to make this 12. Okay, 3 times 4 is 12. 3 times 3 is 9. So I got 9/12 minus 1/12 is 8/12. And then I can reduce that. 8/12 reduces to be 2/3. So that's 27y to the 2/3 power. Okay. And then 102. This was the 4th root of 7 squared, so we just rewrote this as a fraction. Remember, this is the power, and that's the root. All right, so it's power over root. And then we can simplify that. 2 over 4 is 1/2, and 7 to the 1/2. Remember, the 1/2 is the same thing as the square root. So that was 102. Okay, and then 105 is back over here. And this is 105. And the same idea, we've got the 6th root of x to the 4th. So again, I rewrite this power over root. This is 4x to the 4 over 6, but I can reduce that by 2. 2 goes into 4 twice. It goes into 6 3 times, so x to the 2/3. And so that's the root, and that's the power, so that's the cube root of x squared. So you can put that back into radical form. It's a lot easier to kind of manipulate these things as fractions by reducing and then put them back into radical form afterwards. Okay? And then 108. We'll take a look at 108. Now this is where you have to be careful because we didn't stipulate that x was going to be positive and y would be positive. So remember, when you're taking even roots of even powers, that's like the square root of a squared. And we kind of should jot this down. This was one of our rules. The square root of a squared is the absolute value of a. Well, that's because that's a even power, an even root of an even power. So if you take an even root of an even power, we have to use the absolute value. So again, this is my index, and these are my powers, so it's power over root, or my root. So I rewrote this as x to the 4/12 and y to the 8/12, okay? Power over root, or power over index, the same thing. But because this was an even root of an even power, sort of like this, I had to use the absolute value. Okay, now we can reduce these, and this is going to be 1/3, and that's 2/3. And then I wrote this in radical form. So this was the cube root of x to the first power, and this was the cube root of y squared. Now, when I have it in this form, I don't need the absolute value because y squared is always positive. So I don't need to write the absolute value of y squared. That would be, redundant, and I don't have to write the absolute value of y squared because it doesn't matter, because this will always be a positive number. So you don't need the absolute value bar if you know you're going to have a positive number. And then I combine these because they are both the cube root. So the product of the cube roots is the cube root of the product. So I had the absolute value of x, because that could be negative because it's the first power, times y squared under the radical. Okay? So take a look at that. That's a little tricky with those absolute value signs. Okay, then 111. We had this product. And we had 49, x to the negative 2, y to the 4th, all raised to the negative 1/2 power. And then this was just x, y to the 1/2. So again, when we're raising the powers, we multiply the exponents. Now this is understood to be 1, so this is a negative. So I kind of wrote it up. Negative 1/2 times 1 is negative 1/2. And then negative 2 times negative 1/2, and 4 times negative 1/2, and then now these are just factors, no problem. Okay. Pardon me. Okay. Now a negative times a negative is a positive, and then 2 times 1/2 is 1. A negative times a positive is a negative, and then 1/2. I hope that's 1/2. 1/2 times 4 is 2. And then we still have our x and our y to the 1/2. Now, since this was negative, I put it down on the bottom of the fraction. I could put it any time down there. And then I've got x and x. So when we're multiplying, we add the exponents. So that's x to the 1 plus 1. And this is y to the negative 1/2 plus 1/2. Remember, when we were multiplying, we add the exponents. So that's negative 1/2 plus 1/2. Now, I kind of showed what we did up here with these fractions. I'm sorry, negative 2. Yep. I'm sorry, negative 2 plus 1/2. I said that right. Okay, y to the negative 2 plus 1/2. But if I'm going to add these fractions, I have to have a common denominator of 2. So negative 2 is the same thing as negative 4 over 2. That's negative 2. Plus 1/2. So if I got negative 4/2 plus 1/2, that's negative 3/2. And 1 plus 1 is 2. So this is x squared, y to the negative 3/2, and the square root of 49 is 7. And then we don't want negative exponents, so we can put that down on the bottom. And there's your final answer. X squared stays on the top, y goes on the bottom, so that's y to the 3/2, and 7 was already there from the square root of 49. Okay, so I hope that makes sense. That's again number 111. And then number 114, the last one, this assignment. We have this nice fraction with fraction exponents all raised to a power, negative 4. So again, when we are raising the powers, we multiply the exponents. So I wrote this factor, x to the 1/2 times negative 4. And again, we're just multiply the exponents, 1/2 times negative 4. y to the negative 7 times negative 4. Okay, and down the bottom, y to the 5/4 times negative 4. So a positive times a negative is a negative, and then 2 goes into 4 twice, or 2 times. And then I have a negative times a negative is a positive, and 4 goes into 4 once, so I just have 7. A negative times a negative is a positive, and the 4's cancel, or 5 times 4 is 20 divided by 4 is 5. Now I've got a negative on the top here, so I can put this on the bottom and make it positive, or x to the positive 2. And then I've got y to the 7th over y to the 5th. So remember when we were dividing, we subtract the exponents. So I could write this as y to the 7 minus 5, because I've got more y's on the top. And 7 minus 5 is 2, so we got y squared over x squared. And there you go. So that's 142. Hope that helps.